Hello friends, welcome to my channel. In the last class, I explained to you, the last video I explained to you how to convert delta to star. Now the converse I'm going to explain you. So how we can convert star to delta. So this is very important and we can make the make use of this conversion so that the solving of the problems becomes easy in resistance topics here. Now, in the earlier video, I have shown that R1 equal to what? So, R1 equal to, we have already calculated, you can refer back my video. So, RA, RB by RA plus RB plus RC and R2 equal to, this is RC actually, RB, RC divided by RA plus RB plus RC and R3 equal to RA RC divided by RA plus RB plus RC. Now these are the values I already given in the earlier video. Now what I'm doing here, I'm making the product like this. You can see R1 R2 plus R2 R3 and R1 R3. So I am making the product of two terms at a time, R1, R2, R2, R3, R3, R1. You know the denominator will be same, that is the product you are going to get. So the square of the denominator terms you are going to get, that is RA plus RB plus RC whole square is the term that is common for these three multiplications while adding. So first if you multiply these two, the RB term is coming twice, so we are going to get a square for that one. Remaining will be as it is RA RB square RC. When you multiply R2 and R3, RC is twice is there, so it becomes squared. So RA, RB and RC square plus when you multiply R1 and R3, RA is coming twice, so it is multiplied RA square, RB and RC. Now look at here what we can take common among the three terms here. In all these terms we have RA, RB, RC is there. So I can write here take out this RA, RB, RC out of this one. So in the first term we get RB, second RC, third RA. So I'm writing in a order, that is RA plus RB plus RC divided by RA plus RB plus RC whole square. So this term will get cancelled out the square and the leftover term will be like this, that is RA, RB, RC divided by RA plus RB plus RC. So this is what here the product that we are now finding here, R1 R2 plus R2 R3 plus R3 R1 value. Now if you look at the equation, this is R2 equation, so we can find the same here also, that is RB RC by RA plus RB plus RC is there. So in place of that I can write R2 here, so RA R2 I can write. Now bring this R2 to the left side, we get RA value. So RA equal to, you bring this one, so R1, R2, div R2, R3 and R3, R1 divided by R2. So if you separate the fraction, you will get RA equal to, here R2 gets cancelled out R1, here R2 gets cancelled out R3 and R1, R3, I'm sorry here, okay, R1, R3 by R2 we get here. Okay, so this is RA. Now similarly in the same one, if you take RA, RC, RA, RC is here, R3 will be there. So in place of this, we can also write like this, that is R1, R2 plus R2, R3 plus R3, R1 equal to, we can write RB. So RA, RC gone means RB will be there, that is R3 we get. So RB equal to, we can write the 3 where it is cancelling, 3 here and here cancelling. So we can write R1 plus R2 R1 R2 by R3. So this is RB. Now coming to next one, that means if you take RA RB, that means in this one RA RB by RA plus RB is what here R1. So you can also write like this here, R1 R2 plus R2 R3 plus R3 R1 equal to RC R1. Okay, so if you want R1, then R1 equal to R1, where it is cancelling here and here cancel out. So we get what here, R2 plus R3, this is, I'm sorry, RC equal to actually. So R2 plus R3 and what is left here, R2 R3 by R1. This is the third one. So in this way we can get RA, RB, RC values from star to delta. Okay, so please continue watching my channel for future videos. Don't forget to subscribe my channel. Thank you.